Hey, so this is going to be the helper video for chapter 9, and I want to go over a couple of examples from the actual textbook. And the first one I'm going to do is the work it out on page 224, and this is going to be an exercise which is going to demonstrate how we calculate the inflation rate based on a basket of goods and services. So started writing down what we're doing here. So we've got a specific set of items and a specific quantity of those items, and we've got the period 1, so we can think of that as so period, I'll write it out, period 1, price, and then we have period 1, amount spent. Then we have period 2 price. And the same again, period 2 amount spent. They probably could have organized this table a little bit better. Amount spent. And last but not least, well, not last actually, we have period 3 price. Period 3 amount spent. And period 4 price. And period 4 amount spent. Okay, so we put colons on each one of those because we're going to be reading this table from left to right. So the items are, so we've got, let's see here, I'll start here, hamburger, aspirin, movies, and the total, and the inflation rate. Okay, let's see, can I fit that all? All right, there. Inflation rate. Okay, so we're given that in period 1, well, let's see here. It looks like we're going to fix the quantity. So in all periods, we're going to have the same quantity of hamburgers, which is 20. We're going to have 1 bottle of aspirin. We're going to have 5 movies. And the total we don't really have added up yet. So this will be our quantities. And then we have the prices. So in period 1, a hamburger costs $3. Aspirin costs $10 a bottle. Movies are $6. Holy cow, that must have been like a long time ago. Movies are $6 each, and then we can see that we can calculate the amount spent. This will be 20 times $3 is $60, then 1 times $10 is $10, and then 5 times $6 is $30. And the total ends up being, we add across this way, so 60 plus 10 plus 30 gives us 100. All right. And then we do that for the next 4 periods. So in period 2, the price is $3.20. Aspirin's the same, $10. And movies went up to $6.50. And let's calculate the amount spent now. So 20 times $3.20 will give us $64. Does that sound right? Let me think here. 20 times 20 cents is $4. So yeah, so that's $64. Again, 1 times $10 gives us 10. 5 times $6.50 gives us $32.50. And when we add this across, we get 64 plus 10 is 74. 74 plus $32.50 gives us $106.50. And now let's do this for period 3. We have burgers went down to $3.10. Aspirin is still $10. And movies are now $7. All right. So 20 times $3.10 gives us $62. Again, we're spending $10 on aspirin. And we're going to be spending $35 on movies. And when we add that, we get $107. And the last period is burgers go back up to $3.50. Aspirin are still $10, and movies are now $7.50. We take 20, multiply that by $3.50, and we're going to get $7, or $70, I'm sorry. 1 times 10 makes $10, and then 5 times $7.50 makes $37.50. Add that across, and we'll get $117.50. Okay, so we now have the price of our baskets. Okay, so with these prices here of the baskets, we can actually calculate the rate of inflation. So we're going to use that inflation rate formula, and I want to know what is the percentage change from that price of the basket to that price, and then we're going to go from this price to this price, and lastly from this price to this price. All right, so we're going to keep track of how prices are growing average, because again, there's multiple goods here, and you know, it's a fixed basket because the quantities haven't changed. And we're going to use that formula we had. So here, let me do this in a different color just because it's kind of a different part of the problem. So the inflation rate here, so inflation rate, it's going to be equal to the new price of the basket, which is $106.50, minus the old price of the basket, which was $100, divided by the old price of the basket, which was $100. And we're going to multiply this by 100. And what we'll see is, as you can see, we've got a unit here. So if we just divide the top and the bottom by $1, you know, the units cancel. And we'll have this 100 here cancels with this 100 here. And what we're left with is 106.5 minus 100, and that's going to be equal to 6.5%. Again, don't forget, we have to put that percentage sign there because we multiplied by 100. Right. So here, the next year's inflation rate is going to be, just using the same formula, it's going to be, again, the new price of the basket, which is 107, minus the old price, which was $106.50, divided by $106.50 times 100. And again, we're going to have that our units will cancel, so those dollar signs go away. But we can't really cancel this value here. So we actually have to do a little bit of math here. All right, so this is going to be equal to, let's see, 107 minus 106.5 gives us 0.5. So it's going to be 0.5 divided by 106.5 times 100, right? And if I just plug that into my search engine, I can actually do that. So 0.5 divided by 106.5 gives us 0.00469. And let's just multiply that by 100. So times 100. And that gives us 0.469%. Right? So you need a calculator to do something like this. If you were to see something like this on an exam, I would expect you just to, leave it like this. Don't simplify it at all because you would need some type of calculator. And I'm not really interested in how well you can punch numbers into a calculator. Okay, I'm going to close the door. There's some background noise. Okay, and then we need to do this for the last year involved here. And so let's go ahead and do that. So disinflation rate here, using the same method. We're just going to plug in the values into our formula. I'm going to just leave this unsimplified because that's totally fine. All right, so this will be 117.50, and that's in dollars, minus $107 over $107. And then, like we said, we're going to multiply by 100. And the units cancel. Do that in a different color here. All right. And that's just going to be equal to, we can kind of do this in our head. So $117.50 minus 107 leaves us with $10.50, right? Because if we add $10.50 to 107, we get that. So that's going to be $10.50, or 10.5, I should say, because we cancel the dollars, divided by 107 times 100, right? That's going to be the final answer there. If you were to plug that in, you would get what's in your textbook, all right? Okay, if there's any questions on this example, please reach out via email to me so that I make sure that you know how to do these, because this is kind of important. The next thing I want to do is I'd like to take a look at table 9.3 in your textbook. So this is a pretty important table, and I alluded to it earlier on in the lecture when we said, where do we get these index numbers from? So, and again, this is an index number example. So one thing we have to do is we've got to pick a base year. That's every time you do one of these, you'll be given what the base year is that I want you to actually use. So we have to pick a base year. All right, so here we've got period 1. Period 2. Period 3. And period 4. And we're going to do what the total spending is. So total spending in that period. So for period 1, it's $100. For period 2, it's $106.50. For period 3, it's $107. And like we said, for period 4, it was $117.50. And all right, so we want to pick a base year. So which year do we want to pick? Your textbook picked period 3. So I'm going to choose period 2 just to change things up a little bit. So it's going to be period 2. All right. Okay, so the index number is what we're going to need to calculate now. So the idea here is so I don't know if you remember this in lecture, but for whichever year we picked as our base year, so this is period 2, we have to make this somehow, we have to make this equal to 100, right? So here's a quick sort of a trick here. So how do we make $106.50 equal to the number 100? And it's going to be two simple operations. So we're going to turn this into the number 1, and then we're going to multiply that by 100. So we basically have to go, all right, we're going to take 106.50. We're going to, I should definitely do this in a different color. We're going to divide by $106.50. And then we're going to multiply by 100. And that's going to give us 100. All right. When we do this to every single year, so you see this blue, whatever I did to period 2, I have to do to these other ones. So I'm going to divide everything by $106.50. So we have to divide it by the base year and multiply by 100. So I'm going to divide this by $106.50, multiply that by 100. And we're going to take $100, divide that by $106.50, and then we're going to multiply that by 100 as well. All right. So here, these are going to be a little tricky to calculate. All right. So, you know, but we can still do some things to this. So this, if you can see, it's going to be the dollar signs cancel because we're dividing these. So the index number here is going to be equal to, what's 100 times 100? It's going to be 10,000. So that's 10,000 over 106.5. Right? This is already equal to 100 because it is the base year. We already know that in the base year, the index number is always equal to 100. This one's going to be 100 times 107, which is 10,700. So 10,700 divided by 106.5. And this last one is going to be equal to 11,750 over 106.5. All right. And we can also calculate the inflation rates between these here. So let me do this in a different color here. So here, to go, this inflation rate here is going to be this value minus that value divided by that value. So we're looking at 100. So this will be the inflation rate. All right, so we've got 100 minus 10,000 over 106.5 divided by 10,000 over 106.5 times 100. And then from this year to this year, let's call this number 1. This one's number 2. All right. So number 2 is going to be the new year minus the old year over the old year. So that's going to be equal to 10,700 over 106.5 minus 100 divided by 100, and all of that times 100. Put parentheses around this. And then the last one, this number 3, just filling in the blanks here. It's going to be 11,750 divided by 106.5 minus 10,700 over 106.5 divided by 10,700 over 106.5 multiplied by 100. And this one we could actually simplify, I think, because everything is divided by 106.5. So this one's actually going to be equal to, so you can see everything is divided by 106.5. So we can actually multiply the top and the bottom by 106.5 and get rid of that. So this ends up being 11,750 minus 10,700 over 10,700 times 100. Let me see if I can do this any simpler. So this will be equal to, so there's a 50 here and a 1,000. That's extra. So that'll be 1,050 over 10,700 times 100. You see this 100 here can cancel these 2 zeros here. And then that just gives us 1,050 over 107. And this will be in percent. And I don't think this can be reduced any further because I think 107 is a prime number and this doesn't divide out with a prime number because it's an even number. Okay, at least I think. Well, yeah, I don't think that can be simplified any further. 1,050 divided by 107 gives us 9.813. I think that's what's in your textbook, 9.813. Okay, so with these simple mathematical examples, I think you can do most of the quantitative problems in the back of the chapter. There's a couple of other questions I'm going to assign you on the to-do list. Speaking of which, I still owe you a couple of to-do lists to work on. But this is all I wanted to cover for the helper video, and I'm going to post this now. And again, if you run into any questions about how to do some of these examples, please reach out to me via email. All right, we'll talk to you on the next one.